and we hope you'll stop by and see us. We'll be out there very shortly. First, we want to show you some magic tricks, and Matt has us moving back and forth this morning.
Yes, we're a little mobile.
I think we should do this one first, otherwise I might fall. We're both on skateboards right now.
I'm going to hand this to you then in case I...
Oh, okay.
Well, you know what? Let me show first, because we need to demonstrate.
I think that's just so much fun.
What is
what
this?
exactly we're doing?
This is just... Oh. It's just one of these, it's a cheesy illusion. That's what that is. Okay, there was not a lot of physics there, but there was a lot of chemistry because we had flammable nitrocellulose and things like that.
So basically, what do they use that for? Is that for the poof?
Yeah, it's sort of maybe to distract you from something else that they're doing or to make a point.
Do you have any magician friends that you're giving away all their secrets?
No, I don't know any secrets. That's right, I don't know.
But we're going to try and explain.
But anyways, what I wanted to explain was why this magic wand does what it does, and what it does is when I release it in my hand, it wasn't supposed to do that, but when I did it in the last segment, it expanded and it ended up in the middle of my hand like this. Part of it went this way and part of it went that way. That way my thumb got stuck on the end, which is why I did that stupid thing. And the reason it sort of ends up in the middle like this, my hand in the middle, is because of Newton's second law, which says that if you have a system of objects, if there are internal forces between these objects, like for example there's a spring here that pushes one side away from the other side, then if there's only those internal forces, then the center of that object isn't going to move unless there's something on the outside pushing on it. So we're going to demonstrate this with you two guys.
Okay.
So you are now two...
So now that's why we're on skateboards.
That's right, yeah, you are two objects, two particles, okay, and you're going to push against each other. Give a big shove.
Whoa.
Okay, that was an internal force, but there was no outside forces pushing on you too. So what happened was, the center of you at the beginning is right where my hand is.
Right.
Do it again, okay? Give a shove, and afterwards you went this way, you went that way, but your average position, the center of mass of you two, is exactly in the center. It didn't move at all.
Can we get down?
Yeah, you can get down.
Because I'm afraid I'm going to fall.
You were kind of worried, weren't you?
Skateboards.
Okay, so in the case of this thing, the same thing happened. There's sort of this springy action which shoves one end of this thing in one direction, one end in the other direction, but the center of this thing stayed in my hand the whole time.
So once again, like you always prove to us, there is some science behind what's happening.
There is some science, that's right.
And what I want to use this in class today, too.
I'm going to do it in class, yes. We're doing Newton's laws in my class.
Class at 8:30?
At 8:30.
See, so if you have all of your students watch the required viewing of the morning show, then maybe they can get a little head start on the lesson?
That's right.
Maybe they're up this early?
I'm not sure they are. But anyways, this is the year of Einstein, so I want to take a few weeks in the future and talk about the stuff that Einstein did and do some demonstrations, and maybe we can do some exploding gas balloons next week.
Well, we always like that.
We like exploding.
Yes.
Thanks, Matt Sellen, Professor of Physics at the University of Illinois, for being here this morning.
And our wise guy. If you have questions for him, if you'd like to see how something works, you want to know how magic tricks work, or of course a couple weeks ago we talked about the golf game, I'm still waiting on that. Send those questions in to us, the morning show at wcia.com.